So hi everyone, I think most of you know me myself, but I'm Osmish from the Viper team. You'll see me in Crossfire Markets every now and then, most of the time now. So last September, October, between then, we had the opportunity to attend, clear?
It's recorded?
Okay, cool. We had the opportunity to attend CPPCon, which is pretty much like the aficionado C++ conference. It was really cool. We just want to kind of take you through stuff we saw at the conference. But first of all, how many of us are C++ developers or have dealt with C++? Four? One would hope, but it's also a free meeting, so I don't know.
With no donuts.
We get a lot of bad rap for being a bit archaic and stagnant in our technology, just being old because we've been around for such a long time. But pulling up Stack Overflow's research from last year, the survey, out of the main languages, I won't count SQL, and let's not count JavaScript. We pretty much sit in the top 5 of the most used language, mainstream language, both online and on desktop. And we sit on, I'm going to count it as the 4th highest demanded language as well. So clearly there's a need for the language to grow, there's a need for language to be used, a lot of application. And one interesting thing is that even though C# is not even old enough to drink yet, it came out in 2001. Let me just accept this meeting. Oh no, is that? How does that work? We're good? You click, okay.
They probably can't hear you.
Oh.
Check the messages, bottom left. Bottom, yeah.
Hello. Okay, hi people.
Did you read what he said?
Maybe he said he could hear you, but you just need to speak up.
No, you're gonna have, yeah.
Are you?
Yeah, bottom left hand corner.
Bottom left?
Oh my god.
No video
Oh,
either.
Do you share screen?
Oh, that is.
Start.
There we go.
Smooth.
Hello. Hi.
Do you share screen now?
Fuck.
Then
Tell me
same
which
page?
button to
Third
press.
one, next to the end call.
Okay.
And then, yeah.
I mean,
Beautiful.
yeah.
Okay. I hope you're all good now.
And now you want to.
Are we good?
Yeah, we can hear you fine.
There were 10 people and one person. Out of 10 people, one person decided to make a comment. The rest just sat there and looked at a blank screen.
Okay, so if you're just joining us now, I was kind of taking the guys through where C++ stands in the industry, how there's still a very high demand for our language, and that obviously means that we need to be growing in terms of tool set and functionality and new features. One interesting thing that I noticed was, even though C#, here's my joke, is not old enough to drink yet, it came out in 2001, its decline is much steeper than C++'s over the time. C++ is 34 years old. So clearly we have staying power, and if you need an example of staying power, that's Roger Federer. He is 36 years old and he just won his 20th Grand Slam. So clearly things get better with age. The other thing is that in terms of features and functionality and just language growing, every few years the standards committee gets together and they introduce a crap load of new stuff to the language. These are things I'll be talking about just a little bit. And this is what's slated for the next few versions coming up. Some of these are already in the language as experimental libraries. And it's just thanks to these guys who get together every now and then, work really hard and try to improve just our quality of life as C++ developers. Coming up to examples and code talk, you're going to see a lot of context bar. And I know that generally in our work, especially in the Vibe team, we don't really tend to use this that much, but it has become this keyword that does so many different things in so many different situations. Essentially, when you see context bar, just remember that it's compile time resolution or evaluation of your code, and you can run things at compile time instead of actually waiting for the program itself to run. So context bar is really key in the future of C++. You'll be seeing it a lot in the examples. And if you need a little more information, there'll be a few QR codes flying around on our slides. So if you want to zap something for more information, there you go. There's a tiny URL link for what the F is context bar and CPPCon. If you're interested, you can ask me afterwards. I'll just show you the slides and you can zap them. And the other thing you'll notice is auto, all the things. This is very contentious because A lot of people don't like having this generic keyword for any variable type. But if herb starter, who's like the OG of the standard, can have this huge motivation for almost always auto, I think I'm okay implementing auto wherever I can. Most of the slides content to do with language and C++ features in general are taken by Brass Lelbach's talk at the conference himself. That's the most recent photo I could find. I don't think he minds me using it because he put it up himself. But you should definitely check out his GitHub, his apt code. He works at NVIDIA in the CUDA technologies. Yeah, he's pretty kick-ass. So for the first half of my bit, I'm just going to take you through the language features, and then we'll jump on to library features. This is a curated list. This is a shortened list of new stuff. There's way too much to cover, so I won't take up too much of your time. Just to kick things off, I think we all sort of have the situation where we have a struct of a bunch of members, and yes, okay, fine, you initialize this thing, and all of these members are holding a value, and you want to pull data out of it. And you can't exactly just iterate through it easily. So you have really lengthy assignment code where you have value being taken on, you have a variable taking on the value of each of those members. There's different semantics for the ref of that, and it's kind of cumbersome. It's kind of frustrating. Well, people worked around this by using tuples, and used it to assign quite a few of these into the object or the object into that. The problem is you have logical errors like this, which you aren't warned against. You can't do it for ref because if you just declare these and then tie them, you get a compile error because you have an uninitialized ref. And for const, again, once you declare these, you can't then just assign values to them. So there's a lot of problems with this. Also, if I'm factually incorrect here, forgive me. You can interject with questions if you need to. But with structured bindings in CPPCon2017, you have this really awesome syntax that says, hey, auto, for any variable type, given these names, I can just assign you to the members of that object. And that's cool. It's easy syntax, and it also really just, it works for indirect type. I don't know what other points I was trying to make here, but it does apply to const, autoref and refref as well. That solves the problem. The requirement though for using this is that all of your members, or your non-static data members, have to be public. They have to be direct members of the type that it's conformed to, or of the base type. And it can't have any anonymous union, so you can't have just weird compilations of things or package data. Otherwise, language is not going to know how to interpret that and map it to whatever you're assigning it into. That, or you can implement object get methods that are ADLable, which just means that it knows, given the arguments, which version of the function to call, and it needs to implement tuple size and tuple element, so that the language actually knows how to do the mapping. This is cool. I like this. Its uses are quite broad, especially if you do weird things like 25 different arguments that need to be passed from config into some part of the program. It's quite nice. You're also quite used to doing stuff like this, right? It seems quite general. Hey, I have an also something, or an int or something, the result of having done an operation, and then an evaluation on the operation. So if I found happiness and it's overrated, I perform some sort of operation. We've gotten so used to this that I don't think people really think about having this as just a temporary variable that only pertains to this code block and is kind of useless after that. So what they've done is they've allowed you to take that initialization, shove it into the select statement. So you have what's I equals the find operation, and then using the result of that for your evaluation. It might look cumbersome. I think it is. There's also some things that people disagree with, which is just visibility of the scope. So it works for select statements as well, and switch statements. But if you look at the scope of these, if I initialize something on top here, of course it's available for this most immediate code block, but any other branch following that also inherits X. So because I initialize Y, I get X and Y, and in the else statement, which doesn't do any initialization, you still have everything that's declared before it. As soon as you leave this branching logic, they become baby scope. I don't know, it's up to you. I don't have a problem with this. I think it's quite nice that they're trying to streamline the language. The other thing that we tend to use a lot, especially with like the first topic, is periodic functions. Functions that can take more than one argument, or one to many arguments. And traditionally the way we'd handle these is sort of like this case where, okay, let's say I want to print something with just one argument, and then I want to print something with one or many arguments. The one or many arguments version of that calls to the just single arguments version, and then he passes the rest of these on until you sort of recursively get through all the arguments. It's very cumbersome. It's not super intuitive if you haven't seen this code before, and it can get very complicated. What they've done with if const export is they've said, okay, so we can evaluate at compile time the size of these arguments as you iterate through, and we'll create by the compiler, not by you, all the sort of framework that you need to process this in the same way. You'll pass in just a variable amount of arguments, and you if const export on the size of it, and just pass the print function through. It's a lot cleaner, I find. I don't think many people tend to do the first version anyway, so I don't see why that can't be adopted just quickly. Have I skipped? Yeah, the other cool thing is your structured bindings where you have all of your members. You want to iterate through, let's say you have 3 members that you know about, and you want to call them directly. It's very handy to just have like a for loop running through with an iterator or with an index and a get function that handles that. Previously, you'd use a sort of syntax where you get at each of those indices, you'd get for the 0, the 1 case, the 2 case, and it's still also very cumbersome. And this is kind of why people don't like writing a lot of C++ code from scratch, is because this kind of stuff is rubbish. And anytime you add a member, you're going to have to add another function for its calling case. It's a bit more streamlined. You pass in the size, and if const export evaluates I with if else checks in just one code block. You have your first index returning the ID, the second index returning the name, and so on. It's pretty much just adding an if statement instead of an entire function of every time you add a member variable. So I like that. Something contentious, and I know Colin and myself had long conversations about this. Many things, and I find disagreeable, is this concept of fold expressions. I've had a lot of time to come to terms with it and how it works, but effectively it's kind of okay. So let me tell you what it does. It takes a parameter pack, and it gives you a Boolean result out of an operation performed on it for one of these many different operators. The problem I have with this is it's very conditional. There are lots of weird caveats and edge cases, and these don't all perform the exact same way. Documentation on it is extensive online if you care enough to look. But my recommendation is to give it a pass unless you've sort of grown up with this. There are also weird conditional things, just having one left-hand side and all of that. It's not great, but if you can explain this to me, please. I'd love someone to teach me that. Moving on, this is fantastic. So previously, you're going to make a tuple, you'd have to specify the data types, an int and a double. You'd call a make tuple and assign that to an auto, because that just passes you the return pointer or however constructs, I'm not quite sure. But it's kind of a lot of overhead to specify exactly what's in your brackets, especially if you don't actually care. I want this to hold a value of 42, I don't give a shit what it actually is. Now, the language agrees with you. They're like, okay, cool, construct a tuple or anything else with the 42 and anything we want for, and we'll decide how we allocate the memory for that. We'll decide what it means to you. So that's cool. No more specifying in angle brackets your data types. It's another example. If you were newing stuff on the heap and initializing with those values, you could do the same thing. Just leave out the data types. I dig it. It's just easier. And deduction guys themselves. So I don't know this well enough to explain it perfectly. But effectively, what you can do is you can say, okay, here's my template, and I'll give it a type name, and I can say, okay, let's say every time I pass through something that matches this definition, what I want it to do is what's on the right side of our fancy arrow. So if I call a standard vector with these initialized variable values, it's fine. It will work the way it's always worked, or how the language sees it fits to execute this. But if I pass in, for example, these iterators, which I've defined in my deduction guide, it's going to resolve them in that same way. It's going to use those iterators to initialize in a very specific way that you specify. That's kind of cool. I haven't had a chance to use any of this, but I'm sure quite a few of us might. And even better, so generally when you do some sort of synthesized parameter passing, you get so used to setting it up in that, okay, it takes the type and then you pass in the value, that we forget that it would be so cool if you didn't have to. So AutoV lets us do that. AutoV just says, cool, pass in the value and I'll perform all of the other work for you on the code. And I'm not going to explain technically how that works, even though I watched like 3 videos on it. But it does, and it's simple code, and I like it. So just quality of life stuff. Variables can be inline. I think the thing to just realize is every named inline variable that exists in separate files or separate translation units have to be of the same name, have to share the same address, they have to possibly have the same value as well. So inlining variables the way you would functions is not super useful, but it's a thing. So have that, give that a look if that means anything. And even more quality of life stuff, just having nested namespaces. The old syntax would have you just indent and indent and indent to death until you realize again it's one-liners. But one-lining is also crappy, so we have awesome super cool semicolon type looking stuff that just makes things easier for you. And the last little bit of cool language functionality that we have is this really interesting concept of if has include. It's not like an if defined or if not defined defined. All it really tells you is on my file system or in my relative paths, can I include this file? And that seems weird because why would you have code calling an include if the files are actually there? But if you release a library to different platforms or frameworks or OSs or whatever it is, and you want to include all of these files that aren't ever going to be included, you can use some really cool conditional logic to do if includes, and people that compile this will just have a very minimized version of your package. So that's nice. Again, it's just a check to see if the files are in the system. You'll actually have to include it yourself based on the evaluation. So that's nice. Yeah, I can see a lot of typeface already as I expected. Sorry, I'm about halfway done. But if anyone has any questions right now before we get into the library features, anything?
One thing is the use of what is it? The ghost expression for evaluating internal members with conditionals. Is that extended to switch? Or was it only?
Yeah, it should be. So all branching statements are treated the same.
Like the way it mimics, and that analysis that mimics loops. So you get the same kind of scope implications.
Yeah, I mean, I'm not sure how they actually got all the plumbing to work or what sort of.
Well, that's the way you can do this without an if. It's literally exactly the same syntax with an extra semicolon.
I did not see that, but yeah, for sure, exactly. Well, cool. I'm glad they actually thought about it. So, okay, so moving on. We can take you through just a few small library changes. Help me. Are we okay?
Yeah.
Cool. So, I mean, again, this is a curated list. There's a lot of new library changes. These are the ones I found most interesting and maybe useful. First and foremost is string view, right? So, let's say we have the trivial case of, we have a nice string, we want the first 3 characters from it for some reason. We'll pass it in, we'll suppose that's in the substring, or if it's smaller than 3 characters, we turn back out with the string. But we can just call a substring and it turns out that's quite simple, you know, it's not really C++ or anything, it's just how it goes. The problem here is substring itself does an expensive copy of a string. It doesn't just manipulate on the string or issue through the string itself. I do not know this. And it may allocate memory, or even more memory because of that. Even short string optimization doesn't come into play here. So it's kind of problematic, especially if you're doing like thousands of these from like database records or something. With string view, what we can do is call it essentially the exact same way. You know, we'll pass in the string view instead of a string, and you can construct a string view out of a string. I'll explain what that is just now. And it forms a relatively cheap copy. It won't allocate any extra memory, and it will be possibly quicker because of that. By the way, sorry about no syntax highlighting on my slides. You guys are technical, I'm going to assume. So it's fine, you all code people. Yeah, so the main difference is, you know, heap allocation isn't a thing. the string view is a non-owning view of the string. He doesn't actually own the contents, so he can't manipulate the contents safely, and he shouldn't be expected to. But his copying is cheap, his parsing style is by value, but that's okay because all the string view really is a pointer to the string that he was created out of, and the size. That's all. He's like a struct that says, hey, pointer and size t, and that's how you initialize it. The problem with that is a lot of people tend to swing their hand up. What happens if I change my string? Does my size change in the string view? No, it doesn't. What happens if I lose control of that string, or it's destroyed, or it starts pointing to something else? Your string view either is dangling, or he's pointing to something that he wasn't aware of, and is wildly inaccurate. So yes, there are merits using string view. There are many merits using string view, but it's potentially dangerous. I think one of the limitations they put out on this was do not return a string view from a function. Perform your manipulations, copy that result into something, into buffer, whatever it is, and be gone. At least the purpose, I think, of string view. And I think it's quite brilliantly said, also by this example where you would think it's a stand-in, sort of like just a drop-in, but the interfaces are different. So the substring call takes the length in string view, not the final index. That is not okay. In fact, my call there, my call there is correct. So just be careful when you use new library features, especially understand what they do and how they differ from what you're used to, because it's potentially dangerous, and this will break code. And I think it's quite beautifully said by Mr. Jesus.
Yeah? We all fucked up with string view. Sorry, that's on video, huh? No, I didn't say that.
I just found that really hilarious, especially because on that slide, he kind of has things saying that it breaks almost always auto, to not return out. Don't convert from a string to a string view and back again, because that's going to kill you. So, with caution. With caution. This is something I love. So, stood optional, right? It adds a null scape to the value that it grabs. And that's pretty cool, because things like these primitives, just on declaration cannot be null, because they still point to something that won't be null. I'm looking at problem to see if this is actually correct. It is, right? But sometimes you want to return out 0 as a legit value, and you want to return a null as something, as an indicator that, it's a legit part of my code execution. I want to have the full range of in the trivial case, integers. I can do something like stood optional, which says, hey, the int that I'm declaring here, can it be null pointer? Yeah, I can. If I default initialize it, is that null pointer? Does anyone want to guess? Yeah. And, no, and everyone who's nodding their heads is kind of wrong, I'm sorry. Because the value there is 0, which is not being the same as null. It has a numeric value of 0, and we want that. Very often we do actually want the integer to be something. If I just initialize to 2, obviously, that's cool, but that's where I was kind of pissed off. I was like, well, I want to use my I, and I'm returning this value. How do I get that? Anyone who has a guess, especially seeing as that's the syntax, how do we actually get the value out of this? It's trivial. You just dereference it, because essentially that's a pointer to the value. So, done. The other cool thing is, by doing so, you can then perform any operation on that integer. So this is cool. I actually needed this I'll show you the demo at the end, and I'll come back to this. I haven't updated my compiler or anything with my Visual Studio version, so I wasn't able to use this, but it's handy. So stood optional doesn't perform any heap allocation. It does own its contents, as you saw. The copying of its contents in 2dots is kind of dependent on what you're copying, which is understandable. But when it's empty, no one cares, because it's just pointing to nothing. Its parsing style is going to be the same, so if you're storing a ref within that, if you're wrapping a ref up, you'll have to pass that as a ref, or you expect that to be passed as a ref. So very cool feature. I'm actually really fond of that. Moving on to this scary crap. So I think the Bible guys are quite used to using variants, especially in things like Windows externals, where you have. I like Dion's face right now. So this is from the Win SDK, the 7.1 Win SDK, and all you have is, I don't know if you can see, but a union of every conceivable data type that Windows supports, and then a description up there of the variable type, and that's just explained via a comment what each of those can be represented as. So let's say I create a variant, like, hey, you're a variant of type string or bstr, and then I shove the bstr into this union, because this all collapses into whatever you store as just one thing. When you're trying to get information out of it, you'll say, hey, okay, are you, is a v type of bstr? Cool, okay, then I can interpret whatever's in here as just that. It works kind of cool, but it's kind of dependent on your definition of things. Even if I want to make my own variant, I wanted to have a boolean, integer, a double, and a string. Then I need an enum to define these, and then the data that I'm actually pulling out gets access to here. The problem with this is anytime I update something up here, I need the kind type to be updated, and this is source for a lot of bugs. It's not a really nice way of performing this. The language now supports that of the box, so that's how you declare up there a variant of these types. That'll all collapse into each other, and you can initialize in that way with a type passed in. Really cool, very nice. The only problem is accessing that data now. So what they decided to do was leverage off, no heap allocation needed. It does own its contents, obviously. The copying depends on the type and the parsing style as well. But here's the thing, if I want to access that data now, I need to use std visit, and doing so, I start with a try understanding. I vaguely get it, but it's so much of boilerplate implementation, variable passing in and having implementation for processing those. Honestly, I think this can only get better with new versions of the language. But if you're really interested, there's a QR code. Go ahead. That'll help you out. I think it's cool. I just hope that accessing data from a variant is easier in the future. Then we have std any, and then the standards committee surprises me again because, I'm sure at some point someone said, hey, okay, we have auto and we can assign, any variable type to auto, or any data type to auto. Why can't we just say that, my data structure is of auto? And they're like, sure, okay, fine. Let's do this std anything. And std any pretty much just says, hey, my vector can have anything pushed onto it. It can contain anything. And I sense a little bit of worry from those that are still with me, because when I'm accessing this, surely I'm about to break. How the hell am I supposed to know what the 6th index in my vector is holding? Well, accessing this is not too bad. I can create the kind of thing that is holding by dot type. But if I really want to, if I don't know if my I don't know if this range for loop syntax is correct. This is assume it is. But every time I'm accessing this member and I'm like, okay, cool, I want the string out of it because I know how I'm consuming it, obviously. I do this any cast, and I say it's any cast of a constant string ref. Please, the index that I'm at, can you interpret it as such? That will work until it doesn't, because I don't have a string. So it throws an exception. So this is no exception there. You have to do try catches if you're checking through. But I still really love this. I still like this. I still think it's very useful. If you don't mind having your try catches that aren't handled because you know that I'm accessing something that's like a potato object instead of just a string, then it's fine.
Presumably you can still use type of, etc. Presumably you can still use the type of, etc. too.
Yeah, so you can still deduce exactly what it needs to be.
So it's a contrived example that is prone to failure, but you would never really do that anyway.
Exactly. You know what you're consuming, you know what types are possibly going to be in there, and you can check for the type before you even try consuming them.
Yeah.
So it's not really an issue. I do really enjoy this. I love that the language is doing this, and there are people who, I'm swearing a lot in this talk, but there's a lot of people who've been bitching about this. Just trying to get slides together and say, std any, okay, cool. And there's like posts of people moaning, wait, why? This is awesome. As like someone who's using a side project, this is cool. So don't use it if you don't want to. If you really care about things like non-threading and getting a lot of performance out of your tasks, especially if you're doing things like I tend to like with pixel manipulation and huge like arrays of like small little items that you need to just get to quickly, this is cool. standard algorithms can support things like sequential, parallel and serial processing, as well as whatever that is. And it gets very deep. There's a lot of convention, but the easiest win that I found is literally just taking something like std sort and passing like power or std sequential into it, and immediately just gaining a performance benefit. That is cool. You know, it's nothing for you to just add this in and say, hey, does it execute faster? It does. Cool. So obviously there's a lot being hidden from us, and this gets very deep. But I do recommend that if you're doing something that's very heavy on like matrix manipulation or something, you check this out. That's pretty awesome. Yeah, again, I did not bother diving into this, but CMath is this new cool library of math functions in the language. It borrows a lot from Boost and some other Fortran library that I'm sure like 4 people in the world use. They spelled Newman incorrectly, which is a problem, especially because they spelled it correctly on the SPF one, and I don't see why it does. But yeah, Newman ordinals are a thing, and I think someone should bring that to their attention. Maybe I should email someone. But yeah, this is cool. So this is not just the only thing that's available in the math library. There's obviously common things to game primes and all that stuff. This is just the fancy new stuff that people in financial applications care about. And probably the biggest win, the one that I'm most excited about, is the thing that I was always very sad about. So previously, if you use C++ to try and do something simple like copy a file into a directory, on Windows, you're doing some of your stuff to try and get a path, and then you're using some very Windows-specific shell-dependent type stuff to perform that. It's not portable. It's kind of ugly. It's very ugly. Finally, though, we have std file system. Yay! And it's portable. It's a little bit simpler in syntax. I know it doesn't look that much, but it's very powerful. And effectively, sorry, I wish it was FS. It's file system. This for slide purposes. But effectively, you write this once, deploy it anywhere. It's a much cleaner way to perform just simple things like file operations. And I'm glad the language is moving in this direction. It's about time. Wayde will talk a little bit about some other things that the language has added finally with their code. But yeah, thrilled. So praise the sun. Things are getting much better in a very practical sense. And I know by now this is kind of what you all feel like you've been doing. So I'm going to make it a little bit better for you. I'm going to hand over to Wayde for the final little bit of our presentation, and then I'll come back for a little bit of a conclusion.
Alright, hello everyone. So, moving away from all the stuff that Al's just talked about, what's happening in C++ now and stuff like that, I'm going to be talking a bit on where C++ is heading. This is kind of the far future. We might start seeing some of these things getting introduced into C++ 20, but this is progressing further than that. In particular, metaclasses. So, basically at the conference there was 3 talks on this idea. We had the keynote speak from Herb Sutter on metaclasses, and then 2 talks from Andrew Sutton on reflection and metaprogramming. So I'm going to try to condense that into like a 15-minute talk. So bear with me, try to get the basic ideas through. So basically the goal of metaclasses is to make classes easier to write by letting class authors use a name as a generalized opt-in to get those characteristics. Let me explain that a bit easier. If we take, for example, C# and Java, they've got a interface type, and when you create an object of interface, you get certain rules get applied to that, and certain defaults get added. So metaclasses essentially is giving us as developers the opportunity to create our own interface type, for example, with our rules and defaults, so on and so forth. So why metaclasses? Essentially, C++, they want to make compile time programming a first-class citizen. This will reduce overhead and optimize runtime, So currently, we're already seeing people trying to do compile time programming using template metaprogram, macros, and a few other things to compute values and types at compile time. We are also seeing the standard starting to add things like context spur, which was first introduced in C++11, which gives us now a bit more access at compile time to execute some code or evaluate some code. Unfortunately, these are still a bit inadequate tools, essentially giving people spoons to dig with. So we can see this by some people creating their own side languages and even compiler extensions to get more information. For example, Qt and Windows RT, they've got separate compilers to create their own CPP files, and in Windows RT's the WinMD files. So essentially the idea for metaclasses and metaprogramming in general is to give better tools to developers for compile time programming, so we won't require side languages and compiler extensions to get what we want. So the roadmap for metaclasses so far, there needs to be a foundation built, and the foundation we're looking at, the foundation is including reflection, so we'll be able to get the reflection of an entity at compile time code obviously, so context spurs and stuff like that, and then injection, so actual normal code within the compile time block when it gets evaluated. I'll cover that later on. And finally we get our meta classes, which is generative C++. So looking at reflection, so what is reflection? Essentially reflection is a set of language features that allows us to write algorithms that consume our program as data and allows us to do stuff with. Very high level overview of what reflection is. In C++, they're focusing on compile time reflection and not runtime reflection. With runtime reflection, there's a lot of overhead, and there's been lots of complaints from like the C# guys that it's slow and so on and so forth. So at this stage, C++ is purely focusing on compile time reflection. So for an example, if we take a simple class like animal here that's got two public member variables, int age and a string name, we can get the reflection using some sort of expression. So for example, reflect animal gets us the reflection of animal. We can then perform get a method, use member variables method to get all the member variables out of the reflection of animal, and we can then act on those member variables. For example, making the first member variable private, so int age now becomes private int age instead of public int age. So they're playing around with syntax at the moment. So at the moment in the talks they're using $ as their primary expression. So $entity would return you the reflection of that entity being a class, function, primitive type, so on and so forth. Some operands, for example, ID expression can tell us if it's a function or variable, type ID, namespace name, and then also some methods. So if we wanted to get the name of the reflection, if we wanted to get the value of the reflection. So as I said, the syntax here is subject to change. For example, things they're playing with is $entity, which I showed above, reflect expr for on entity, and then __ reflect on entity. So this is definitely not the final syntax that we're going to see for reflection. So with reflection, a new for loop was required. So essentially here we're looping through some entity s's variable member variables and basically outputting the names of those variables. This expands to the following. Essentially, the reflection and getting the member variables returns us a tuple, and then scopes the tuple per index of each of its member variables. So for example here, we're getting the the member variable for 0 and outputting 0's name. X becomes the reflection for the first member variable, and goes on all the way down. So to get more of an example going here, I'm going to look at enumerators and just go through an example of how you can apply this reflection. So the requirement, attack plan, and sample code. So the requirement, implement a method toString that returns the string value of an enumerator. So the way that we're going to attack this is we need to get the reflection of the enumeration type of the argument passed in. Get the reflections of each of the enumerators. Search that list for the argument, and then finally return the name. Return the declared name of that enumerator. So I'll go through each of these a slide at a time. So firstly, write a normal method. So ignore that it hasn't been finished, but essentially we've taken a template E, and we're going to create a method toString that's got an argument that's in it. So our foundations, where E will become the enumeration type. So attack plan 1, get the reflection of the type. So as I said before, using the primary expression to get the reflection of the enumerations. So auto reflect will be the reflection of whatever E is. Moving forward, getting the reflection of the items, making use of the for loop I showed you before. We've now got a for loop that goes through each of the enumerators and gets expanded as shown above. I'll show further. Thirdly, we can now start searching. So basically we do a switch on the arg and make use of a context per block. So at compile time, this will get evaluated and expanded, and so on and so forth. And then finally, we add the return type. So basically, this is what the code would look like in its final phase. So we'll have our switch statements and the cases, and this gets expanded to something more like this. So this is all happening under the hood at compile time. We won't see this. This is just the visualization of what's kind of actually happening. So a more practical example, if we take animal and plug it into this, so we go to animal, string name equals toString, passing in the type of animal and then the dog enumerator, and we want to get the output, we should get the output of dog. So we then go back to our code snippet, substitute the enum and the reflections, and we essentially get our method that looks like this. Then applying the argument, we get our dog return. So reflection.
Sorry, you don't have to write any of that. This is generated for you, right?
Yeah. So basically, we would write this here, and all the rest would be generated at compile time. Because leveraging off current templates, which only get implemented on at compile time for code that uses them. So yeah, so get our stuff. So basically, reflection in a very small nutshell there. Moving on to the roadmap, compile time code. So as Al mentioned, context spur. It's becoming the new and greatest thing within C++. So it was first introduced in C++11, C++14 added some context spur loops, C++11 you're seeing things like lambda and if context spur, C++17, sorry. There's already proposals for context spur algorithms, context spur containers, and context spur allocators for the future. So this is going to blow up and become a really big thing in C++ for compile time code evaluation and stuff like that. So essentially you could write a chunk of normal code, do your context per block, which will run at compile time, and carry on writing normal code again. And yeah. So basically we've now got the reflection, we've got context per to you make use of our reflection at compile time. And this other thing is to now put code back into our program. So injection is essentially the opposite of context spur or compile time code. And essentially you can have this injection, which is currently being using the syntax arrow and then curly brackets. And essentially within your context spur block, you can now have a piece of normal code in a block. Okay, so very brief overlook of the foundation of they want to build up for meta classes. moving on to metaclasses and generative C++ now. For example, this is a very brief example of if we've got a class point that's got two member functions, int x and y. Essentially, at the end of the day, we actually have a class which has made x and y private, as well as a whole bunch of default constructors, copy constructors, destructors, so on and so forth, which we get for free whether we like it or not. There's already some syntax in, so we can delete those by default, but at the moment the compiler is putting this all in for us. Same thing for this example here. If we've got struct myClass that inherits off base and has a void function if, because it's a struct, we essentially get a class of myClass and it becomes its public base and makes f public. And if base has an f function, automatically adds the virtual onto the f function. So this is what the compiler is doing for us at the moment. If we wouldn't want to make any changes to this, if we want to add our own sort of error handling or rules, so on and so forth, firstly we'd have to make a proposal, become a compile time writer, and yeah, it's not very fun. And so essentially what metaclasses does is it's giving us that middle capability. So if we look at interface, the original example that I showed up with C# and Java, we want to create a interface metaclass. Current syntax is using $class subject to change for metaclass code, and basically interface we can enforce public pure virtual functions only and have some defaults. Then we can actually create an object shape that's of type interface that will get all that. So as the normal class got all that extra constructors and stuff like that for free, now our shape will get what we describe in interface, or what we code up in interface. So typical uses enforcing rules. All functions must be public and virtual. Provide defaults functions. We can actually make the functions pure and virtual. So moving on to an example, implementation example. So our current interfaces in C++, or abstract classes, whatever you want to call them, we have to manually make sure, hey, we've made them pure virtuals, we've no move or copies methods, there's no data, there's no member variables, so on and so forth. And the proposed solution is just interface, area, and scale bar, where interface will make area pure virtual, and scale bar pure virtual, add in, for example, the destructor with no except, check that there's no moves or copies, no data member variables. So looking at the implementation on interface, let me get a pointer here. So firstly, as I said, by getting things by default, here the metaclass interface will add in this destructor for you. We then have a cons expert block that we first can check, hey, compile time requirement, check if there's any variables in this class. That's your shape class. Yeah. And if there is, we can now write a custom error saying, hey, we don't want member variables and that sort of stuff. We can then iterate through the functions of that class, check if there's a copy or if there's a move function, and again, get the compiler to give an error out. Moving on to checking if it's public or private, we can then forcibly make it public, and if it was, and we can throw out a error or warning saying, hey, this should be public, and then finally we can force the functions to be pure virtual. This is up to however you want to create your interface class. It's now you've got the world kind of thing. You can add your own rules, own default parameters, so on and so forth. So how this compares to other languages. So here's C#. Here's an 18-page specification on the interface method. And here's the proposed C++ implementation of interface. It's 10 lines. It's unit testable. It can be shared on GitHub. And as I said before, we can have custom errors. In this interface of C#, you get your generic errors. There's no sort of customization. As far as I know, there's no real customizations in terms of that sort of stuff. So basically, it's just giving us the flexibility now to write what we want classes to get and compile time.
Out of interest, is there a sense that so those final 3 lines there where we've made non-public member functions public, and then we promptly ask, are they public? So presumably the second one would never emit? Or just, it's more a question of how these things get evaluated?
Yeah, no, you're correct there. It actually wouldn't get evaluated in that case. That would always, it would always get caught because you've just made it public. So, yeah, there's
For every single one?
yeah.
Unless,
Well, no, I mean, presumably the require is that this thing is true and it will only print that if it's false, right? That seems more reasonable.
Yeah, okay. So I'm not too sure.
Okay.
So I presume so.
what if make public and is public answer talking to the exact same flag or whatever defines it as being public? So,
Well, if it's the same function, right?
yeah. But, okay, we'll talk afterwards. I
doesn't
think
have
it might still be
access.
valid.
If it has access already, but not public.
I mean, make public must have changed the declaration.
Yeah, it would have changed ifs, because essentially if is now the reflection of that function. So you get to, if you've changed it, obviously if has changed, the object of if has changed. So yeah, this is a valid point. So how does this help us with side languages and compiler extensions? Well, Qt has implemented its own sort of objects and stuff that gets read by its compiler and generates normal standard C++ from there. For example, they've got the Q property, Q object, signals, slots. I'm not going to go into what those are, but essentially this is kind of what Qt looks like. You write your code with headers and stuff, extensions, then goes in parallel to their compiler to generate their CPP files, and then finally off onto the C++ compiler. With metaclasses, you essentially just write normal C++, and you don't need this parallel compiler. Looking at the code a bit more Qt, actual code itself, essentially we can look at creating a metaclass of Q class, which is of Q object and inherits all, and with Q class you get all the defaults and rules and stuff that you require and generations.
Okay.
Okay. Same can be said for properties. So essentially in C# you get a getter and setter type thing. Property basically does that. It adds the functions for getter and setter. So you just say property int, you get your getter and setter for Mahala. Same with signal and slot, other functionality that's been written into Qt and looked at by their compiler. So as the other example, WinRT, again, it's got a parallel sort of compiler where it generates the WinMD files, and then this normal standard C++ compiler which generates your objects, libs, and DLLs. Essentially, the proposed solution is at compile time with metaclasses. The metaclasses can actually generate those WinMD files for you, as well as the standard object, libs, and DLLs. So, yeah, that's what they want to try to do, is the removing of compilers, making compile time programming a first-class citizen. So, where is it going from here? Well, there's a long road ahead. So we're going to be seeing a lot more context-aware functionality going into the standard with C++ 20, C++ 23, so on and so forth. We possibly might see a bit of reflection in C++ 20 as a TS. None of this is confirmed. And finally, metaclasses, still in its infancy. It requires all that plumbing beforehand in order for it to work properly. So, maybe unrealistic, but we might see it around, start seeing hints of it around C++ 23. yeah, so is there any questions around this? Okay, just before I hand back over to Al, some other talks that I went to, just a very small snippet. EA Secret Weapon, basically their take on packaging and modules to generate builds. So they don't have code in a module. The C++ standard is now implementing modules. Very similar idea as to what they've done already. And finally, something Al didn't mention, we've got a networking TS. Networking is finally coming to the standard. Essentially, it's based off Boost Azure. It's a low-level networking library that gives you access to TCP connections and UDP connections. A very fun talk was, so you've inherited a large code base, well, Viper. So basically, we could draw direct comparisons, and things that they talked about was don't make assumptions, don't get distracted, so you're busy going down this path and you see something, you go down that path. No drop-off fixes, pack jobs, always follow through. So when you're making a change, complete it, don't leave it half done. And then finally, if we're going to refactor, unit test beforehand, so you aren't changing functionality. And then, yeah, so with the whole metaprogramming and stuff that Herb and Andrew were talking about, there was another talk by you on compile time reflection. Essentially what he's done is he's made use of third-party libraries, template metaprogramming and macros to get some sort of compile time reflection. So in his library that on GitHub, basically he's got reflections, some serializing and deserializing of JSON and XML, but unfortunately there are some drawbacks to it, and I've played around with it to try and implement it here, but it didn't quite do what we wanted it to do. So yeah, only 4 talks out of the couple of 20 or 30 talks that we went to. Yeah, so that's pretty much me done for this. I'll hand it back over to Al to talk about the C++ and what he felt about the conference.
Yeah, I didn't like this stuff. That's problematic.
Unit test before
Yeah.
refactoring and Viper.
Yeah, sure. Switch to mine. So you guys can breathe a sigh of relief because we're kind of done with the technical talk. I think we did a really awesome job explaining something that's very abstract. So thank you. Cool. It's okay. There's no more technical talk. I just want to talk a little bit about my observations when it comes to attending a conference, and especially a conference of this sort. I think you guys know that C++ developers especially are very technical and have very strong opinions about certain things. They all just tend to be really gifted for some reason. And just, we tend to be gifted individuals. You should be proud of that. But my sort of first reaction when we went on the little drinks and meet and greet night for registration was like, damn, these people are really full of shit. Like, they're really full of themselves. It's very arrogant. And like, it was kind of a put off. But then I really thought about it. And the things that people were talking to me about, they weren't from a place of arrogance, or I mean, they were just from a place of pride, because like we deal with a really awesome set of tools. You know, we can do, when we sit on our computer, anything we want to do in our language. That is freaking awesome. And like when I looked at it from that perspective, I sort of started to really appreciate the way people speak about the technologies they work with and why we are so awesome. And of course we're awesome. You know, of course C++ is the best language, right? So yeah, I think, you know, it's kind of nice to distinguish between what's an arrogant point of view and what's just being really proud of the technology. And when it comes to things like when it comes to things like people saying, okay, why don't you guys have something that's really easy passes through like regular expressions? That's I've always said. Or why can't you do this? Like, why isn't there a networking library just built in? And you know, why aren't you guys introducing this more quickly? I think Herb puts it in a very good way. Just out of respect for the language itself. Okay.
I will strongly agree with you, but I think Bjarne's points are also good. Everything you said, but the abstractions have to be usable, not just write-only, so we have to make sure of that. And for them to make sense in this language, they had better hew to C++'s pillar of zero overhead abstraction. Zero overhead principle, machine near, I can always open the hood and take control. As long as you do those things, then it's C++. Otherwise, we're just proposing a feature that belongs in some other language.
And I think, that speaks volumes about how we should just appreciate the work and what the language really is now, because it hasn't been any better than it is right now. And they will not add anything to jeopardize that. Yeah, the conference, CPPCon is technical AF. Like, I think we used to try and borrow some time to go for the non-technical talks, and I'll talk about this in a second, because it is a huge information overload, and with that sort of technical mindset that Hans has, you kind of walk in there with a sense of imposter syndrome, and if you know what imposter syndrome is, it's kind of like that feeling, I think many of us will get in walking here, is I'm surrounded by all these amazing people, and all these guys who are so knowledgeable, and what the hell am I doing here? The good thing about this is, talking to anyone at any level, you really get a strong sense of community. People are always embracing you, they don't always assume your level of understanding. And I think that the biggest result of that, the best result, is inspiration, because I kind of left there thinking, I left the first day thinking, holy crap, what am I going to be doing here? What am I here to gain? Because I can't easily absorb all of this. And then as the days kept going on, I spoke to exhibitors, and I went to a few different talks about the way people are using their tools and this language, and what their dreams are for it, and how that's coming along. It's like, this is hella inspiring, People do cool shit. And as computer scientists, or as programmers, or as just normal developers, or people who are hobbyists on the side, we have the best building blocks. And for someone like me who just likes to make things that look pretty in my spare time, I'm not trying to solve the world's problems in my spare time. I like making little fun projects. This has been the biggest source of inspiration for me, just as a developer, coming to work and also working on my own side projects. And some of the talks that really motivated me for this, there's YouTube playlists inside there if you want, or you can just tiny URL CPPCon talk, and this number is 127 if you really care. The main class is Grace Again talk by Vinny Falco. I highly recommend you watch this, because even if it's not from a language perspective, it's a man standing there from the beginning, building up this, what was it, like a HTTP request response framework. Doesn't matter what he's building, he explains to you just step by step how you can actually go from the very beginning, building something great that makes sense, that abides with solid principles, that's powerful. And that is in itself inspiring. Then there's the few functions talk, and this has changed the way I dev my side projects completely. Not immediately jumping to this OO paradigm, making classes of objects and instances and calling functionality on those objects. And it's just, it seems weird to think about that as being a negative thing, but passing in an instance of your object with a bunch of data to process, so a free function just makes a hell of a lot of sense. And it makes the code so much more readable and so much more maintainable. And I'll show you some demos of things I did just using this approach. And I can go back now, today, after months of not looking at it, a week of not looking at it, and still manipulate the code very easily. The other really inspiring talk, and I thought I was going to hate this, was Matt Caldwell, who some of you guys might have heard of. He's a guy who has gobble.org. It's like this online compiler and assembly viewer. It's really awesome. And if you want to try C++17 features, visit his site, because you can just type C++17 code online, compile, and see what happens. He pretty much just highlighted a few things about the fact that the guys who write compilers are brilliant people who make your life a lot easier than you think. And reduce the legend. Just check the talk out. There's a lot that happens in the compiler under the hood that you don't always appreciate. Also, don't micro-optimize. Really, the compiler is smarter than you. It knows when a variable should be just declared in line, and it'll do it for you. Make sure your code is readable, and the rest will happen. Just turn on optimizations in your compiler, and you'll be fine. The other thing we thought we were going to hate, holy crap, but there was just that talk and that talk we wanted to go for. And it's probably one of my favorite talks, is designing a fast, efficient, cache-friendly hash table step by step. This dude from Google, he looked at the way they were accessing hash maps across the globe and what the global usage was and the keys, and it was awful. Not the worst thing. I mean, it's Google. They know what they're doing. But he kind of just goes from the ground up, designing this really awesome data structure. And he made a really awesome talk. It's a really awesome concept, seem very simple because it is. Most of the high level, in terms of this complexity, things that you encounter tend to just be broken up very simply because they are simple in the very nature. Everything I want you to know about DLLs. Yep. And then these last two bonus talks, which we attended, I think Wayde and I just loved these. This was Building Better Worlds, which is this guy who works for, I can't remember the name of the company, but they are a special effects company. They do a lot of like CG. They wrote a tool for the artists working on the Alien Covenant film to generate cities procedurally. They'll pass me a few like parameters, just configure generally what kind of vibe needs to be, and they'll just develop the cities out of nowhere. It was awesome. Front end is written in Qt. It's a Python front end. It changed my mind about Qt as a GUI framework. I was supposed to implement my other tool in it, but it's fine. And then traveling the solar system with C++, it's kind of like about rocket science and how they model the universe in our language. That was really cool. And stuff like that really inspired me. I wanted to come back, I wanted to pick up my side projects again, I wanted to revisit my old stuff and optimize. And even if it wasn't in C++, like my Calpica and my font generation tool, that's C#. But I went back and optimized, and it can generate like what 15 million pics in like 3 seconds or something. It's pretty cool. Or even just fun random shit like making glitchy art out of my favorite female tennis player, and we had fun. It's just having fun with your language and having fun with the tools. It's inspiration, and I think that's the most valuable part of attending conferences, coming back energized, wanting to do the thing that you have to do 8-9 hours a day. The other cool thing, especially with free functions, no OO at all, essentially. This is color averaging and edge detection on the image. This is a visual representation of what's happening under the hood. Each of those squares is supposed to be an LED behind my monitor. So the plan for this, when I get the hardware, is to extend my desktop, like physically and visually out. So I'll be piping this to a Raspberry Pi, all these RGB values, and each LED will be corresponding with that in real time. It's just something cool that I've been working on, and I spent like 4 sleepless nights on during the holiday. And it was fun. And I think that's the biggest thing, is even if you're not using CPPCon2017 specifically, going for conference, motivate for it. Try and get yourself in, because I think the most tangible value is just your attitude towards your work and the stuff you do for most of your life as a developer. And having said that, thank you guys for attending. Anything you want to say, Wayde?
I think you've said it all, summed it up.
Okay. Thanks guys. Dinner donuts.